To begin today's lesson, we have a warm-up. Our first problem of the warm-up asks us to write 6 and 25/100% as a decimal and fraction. Remember, when we start with 6 and 25/100%, to change it into decimal form, it's like dividing by 100. So we have to move our decimal 2 places to the left, which results with us getting 0.0625, or 625 ten thousandths. When writing it as a fraction, we've already talked about how all percentages go over, they're part over 100. And then on top, we just write what part we have. We have 6 and 25/100ths part out of 100. Moving on to problem number 2, we have to solve for the variable from our algebraic equation. Our first step is going to be to use distributive property to get rid of parentheses. So we can copy our problem and then distribute as we go. So we have 5 plus 4x minus 7 equals 4x plus 12 minus 2x. Note, I didn't drop my negative. Our next step would be to combine like terms. On the left-hand side, we have a 5 and negative 7. And on the right-hand side, we have 4x minus 2x. 5 minus 7 is a negative 2, plus our 4x, equals 4x minus 2x is 2x, plus our 12. Moving on, I'm going to move all my x terms to the left-hand side and all my constants to the right-hand side. So I'm going to have to add 2 to both sides and subtract a 2x. These cancel, these cancel. 4x minus 2x is 2x, and that equals a 14 on the other side. And our final step is to divide by 2 to isolate our x. And we end up with x equals 7. Today's I can statement for our lesson is I can express change as a percent when working with markups and markdowns. And that's essentially sale prices or price increases. It's a lot of real-world applications. To find the markdowns, we can follow a little setup that we have here. We start with the initial cost of the item. We subtract the markdown, and it equals the sale price, which is what we're trying to find typically. However, note that the markdown, that is, if dealing with money, that's the money off. It is no longer simply a percent. And in order to find the amount marked down, that's when we're going to be using the percent equation or percent proportion that we learned about the other day. And that's what comes into play. We're combining now 2 different things. And always remember that when using percent values in equations, the percent must be in a decimal form. Just as a note to take along. At the top of the page, we have our markdown formula to follow. It's the cost minus the amount marked down, which will equal our sale price. And let's see if we can apply that to solving our new problem. The question asks, when shopping at Piggly Wiggly yesterday, I bought bagels for $2.29. Here's an amount that's probably going to come in helpful. Today in their ad, they are advertising that they are 12% off. What is the new price for my bagels? So, because we're trying to find the new price, that would be our sale price. And when setting up our formula, we automatically, from reading the problem, we can find our cost. Our cost of the bagels used to be $2.29. And we are going to subtract the markdown. However, all we know is that they're 12% off. We do not know what the markdown is. And so that's where we're going to use the percent equation or percent proportion. As an equation, remember it is percentages in decimal form times initial cost, $2.29. You can also do it as a proportion, which would be our percent proportion, 12 over 100, equals our unknown cost over $2.29. What I like to do, though, is write it as an equation and plug that right into my markdown. So, for markdown, I would put in 12% or 12 hundredths times my initial price of $2.29. This right here describes how much of my bagel price will be taken off. And that equals our sale price, which is what we're trying to find. So, when we solve, we end up with getting $2.29 minus 27 cents to get us a grand total of a sale price of $2.02. So, I can say the new price for my bagels are $2.02 is the new price. Our next problem says that at Best Buy, there is a 48-inch television that I've been waiting to buy. This month, the TV is on sale for $1,288.98. The website says that the TV is 45% off. What is the original price of the TV? And as a review from the last few slides, remember that in order to find the sale price of something, we take the cost, initial cost, minus the markdown, which is the percent off times initial cost, and that's going to equal our sale price. However, in this case, we're trying to find our original price or the initial cost. So in this specific case, cost is going to be our unknown of X. We are going to subtract the percent off, or 45%, times the cost, which we do not know, and that is going to equal our sale price of $1,288.98. And now we need to solve our equation. And remember, when we solve, the coefficient in front of this x is a 1. And so 1x minus 45 hundredths x is 55 hundredths x. And that is going to equal $1,288.98. To complete solving, we have to divide by 55 hundredths in order to solve for x. And then at the end, we end up with x equals $2,343.60. And that was the original price of the TV that I want to buy. And there we go. The last few slides have been dealing with markdown, so when something is on sale. From here on out, we're going to be dealing with markups. So when we are increasing prices, something you see this a lot with is gas prices. You buy gas one day, the next day it increased. And using math, using this, we can find the percentage of the increase. And once more, when we're dealing with markups, we're going to start with the cost, initial cost of our item. But then rather than subtracting for a markdown, because it's going up, we're going to add. Then the markup will once more be the percentage up times initial cost. And it's going to equal our new price. And when you mark something up, it's no longer a sale. So it's just the new price. And once more, remember that when using a percent value in our equation, it has to be in decimal form. Do not forget to convert that. Our first story problem dealing with the markups is the following. Last Friday, I bought gas for $1.98 per gallon at Quick Trip. Today, when I put gas in my car, it was 3.6% more expensive per gallon. What was today's new gas price? And just like we have up at the top, remember, it's the cost plus our markup. And remember, markup is the percentage increase times initial cost. And that will equal our new price. So, looking through our problem, I see it was $1.98, and I also see 3.6% increase. So, $1.98 was my initial cost plus our markup. And remember, 3.6% is a decimal, 0.036 times the initial cost of $1.98. This portion will get me my markup, and that is going to equal my new price. When you solve this equation, you end up with getting $2.05. So, to finish up my story problem, what was today's new gas price? It was $2.05 was the new price. Big increase in gas prices. Our final example today states that last month, a painting that I wanted to buy was $14.95. Now, the picture costs $34.56. What was the percent markup in price for the picture? So, I have, looking through my problem, two different numbers. So, I wanted to buy it when it was $14.95. So that was my original cost. Now it's $34.56. This is my new cost. What was the percent markup in price for the picture? And remember, when we're doing percent markups, we take the initial cost plus the markup, which is the percentage times initial cost, and that is going to equal our new cost. And now it's just a matter of filling it in. Initial cost was $14.95 plus percent markup is our unknown. I'm going to actually call it P this time for percent, times initial cost, $14.95. And that's going to equal our new price of $34.56. To solve, I'm going to start with subtracting $14.95 from both sides. This leaves me with $14.95p equals $19.61. To finish solving, I divide by $14.95. And I end up with P equaling 1 3/31. However, remember, because it is a percent, we cannot leave it in decimal form. To change it to percent, we have to multiply by 100 like we've discussed. So moving that decimal over 2 spots, the picture was marked up 131% increase in price. And that is an outrageous increase, but it actually happens a lot at stores.